looking at domain and range of linear functions. Example 5 says, find the domain and the range of the following. Part A, we are given y equals to 3. Y is given as 3. And to sketch this is a straight line cutting the y-axis at position 3. The drawing is not to scale, it is just for illustration. The x-axis and the y-axis. And we have a point on the y-axis 3, and that line passes through 3 in this manner. This is the line y equals to 3. Clearly here we can see that the line is perpendicular to the y-axis and it is parallel to the x-axis. In other words, this line does not meet the x-axis, and as we say, it is independent of x. It is independent of x, or there is no term in x. It is independent of x. It does not meet the x-axis at any point. They are parallel. So our domain here, which is a set of the values of x, is going to be a set of real numbers, because for any value of x that we substitute in this equation, the output value of y will always be 3. So changing the value of x along the x-axis does not affect the function y equals to 3. The function will always remain y equals to 3. That's why our domain, which is a set of the values of x, is a set of all real numbers. In the interval notation, our domain will be from negative infinity up to positive infinity. In the set Euler notation, our set x comprises of real values of the entries, which are the values of x. So this is the answer for the domain. How about the range, which are the values of y? We have seen that this function will always be 3 regardless of the value of x. So our range is a fixed value 3. It is a definite value 3. So our range is basically 3. Regardless of the value of x, the value of y is going to be constant for this function. So in the set Euler notation, we have a set y for which the only element is a real number y equals to 3. It is just a single number in this manner. So this is the range and this is the domain for part A. Going to part B. Part B says f of x equals to negative 7, and we have said this is the same as y equals to negative 7. And if we are to sketch this quickly, if this is our Cartesian plane x-axis and the y-axis, we have y is negative 7. So we have a point on the y-axis here, negative 7. This is our focus, but the other values on the Cartesian plane which we are not plotting. So from here the line y equals to -7 passes through -7 in that manner. It is a straight line. I'm not using a ruler. It is not to scale. So this is our function y equals to -7. And clearly we can see that it is perpendicular to the y-axis and is parallel to the x-axis. Since it is parallel to the x-axis, they do not meet. The line does not intersect the x-axis. Therefore, it is independent of x. We have seen that the function is independent of x. Independent of x. And therefore, what is the domain? Domain is a set of the values of x. And in this case, regardless of the value of x, the value of y will always be -7. Therefore, our domain will be a set of all real numbers. Will be a set of real numbers. And in the interval notation, our domain rather, is a set of the values of x running from -infinity up to positive infinity. In the interval notation, in the z-Euler notation, our domain will be a set x for which all the values of x are real numbers in this manner. So this is the domain for this function. What about the range? We have said that the range is a set of the values of y. So if the given function is independent of x, it implies that y is a fixed value, -7. So our range is -7. It will not change because it is not affected by changing the value of x along the x-axis. It is always -7. In the Z-Euler format, our range y is a set for which the only member is a value of y which is -7. So this is the solution to part B for the domain and the range. Part C. In part C we are given x equals to 18. To quickly skip this is the x-axis, this is the y-axis. We have a line cutting the x-axis at position 18. If our position 18 on the x-axis is here, 18, the line will cut the x-axis at that very point. And we have seen it is perpendicular to the x-axis but parallel to the y-axis. In other words, because it is parallel to the y-axis, this line x equals to 18 does not meet the y-axis, so it is independent of y. As you can see, even in the function, in the linear function, there is no y term, so straight away it is independent of y, does not meet the y-axis. So our domain, which are the values of x, this one is the value of x, it means x is 18. Therefore, we are restricted that the domain has only 18. That is the point when the line cuts the x-axis in a perpendicular manner. So our domain is a fixed value of x, which is 18. So our domain is a fixed value 18. That is the answer. Going to the range, which are the values of y. If you look at the given linear equation, x equals to 18, it is parallel to the y-axis. So y values will range from -infinity up to positive infinity, or in the opposite direction. This implies that whatever the value of y is, the value of x will always be 18. It is independent of y here. Please, I've just noticed I didn't write y. So our range now becomes a set of all real numbers. A set of all real numbers, or simply a set of real numbers. So our range in the interval notation are the values of y from negative infinity up to positive infinity. In the set Bueller format, our range is a set y for which all the entries or all the members are real values of y, and therefore this is the solution to part C. This is the range and this is the domain. Let's go now to part D, which is the last part of example 5. Part D, we are given x equals to 100. And to sketch this, just to get our understanding, we have the Cartesian plane in that format, and then somewhere here we have 100, and a line passes at a point 100 on the x-axis. So clearly it is perpendicular to the x-axis. The line y is 100 is perpendicular to the x-axis and is parallel to the y-axis, or does not meet the y-axis. So we can see clearly that the line is independent of y, simply because it does not meet the y-axis at any point. So our domain, which is the set of the values of x, is going to be 100. It is a fixed value. Regardless of how y changes, the line must always cut the x-axis at 100. So it is a fixed, definite value on the x-axis. And the range, which is the set of the values of y, the range will be any real number, because any real number is defined by 100 for this case. So our range is a set of all real numbers. Set of all real numbers. That is from negative infinity up to positive infinity, just along the y-axis here. This is the positive part going up. This is the negative part going down. Negative infinity, but it is very far below. And in the set Bueller format, we shall have our range is the set y, for which y is a set of all real numbers, and this is the solution. This is the domain, a fixed value 100, and a range is any real number from negative infinity up to positive infinity. So this is the end of us looking at domain and range of linear functions. In the next video, we shall begin to look at the range and domain of linear functions with denominators. We shall have the numerator and the denominator, and then we find the domain and the range of that linear function. So please stay with us. If you have questions, leave them in the comment section, and our experts shall respond to you accordingly. Thank you.